Hello, welcome back to the channel. If you want to know how you can help companies to optimize their product segmentation and automate ABC analysis, you are in the right video. My name is Samir, I'm supply chain data scientist and founder of the startup LogicGreen. In this video, I will introduce a module we designed to help our users from small, medium, and large businesses to create ABC charts and automate Pareto analysis. I will first introduce the mathematical theory behind, and then I will show you a demo on how the users are using this app to basically support their inventory management or provide insights to their top management. Let's go. Let's assume that you work for a retail company that sells more than 800 unique items. Each item has its own specificity. So that's what you can find, for instance, in the master data, but also different demand variability. Their contribution on the turnover is also different. Some of them have a very high contribution. And you want to know how to allocate time and resources to plan the demand and manage the inventory. ABC analysis is a technique used to categorize inventory items based on their importance and demand variability. So for instance, in this chart, the x-axis takes the contribution on the turnover in euros or in the sales quantity. On the y-axis, you have the coefficient of variation. So that's basically the standard deviation divided by the average. And the items can be separated in three classes. So the top 5% are the A class. We are called them the fast movers. These are basically the items that are pushing your turnover. They are very important. The following 50% of SKUs, called average movers, are in the class B. And then the remaining 80% in class C are what we call the slow movers, or you can also sometimes find the term slob, that contribute to a small fraction of the turnover. You can spot specific cases like this item, for instance, with a very low turnover contribution, but a very high demand variability. Or a better example with this high contributor showing a very stable demand. Okay, so now that we have defined the theory, let's go to the app. So this is the LogicGreen app. It's an application that we have designed to showcase the different types of analytics product that we can develop to the companies. And the idea here is that you can test yourself. This is a very simple app designed with fast API for the backend and the front end using Streamlit. You can test yourself the different models that are presented in the case studies that are published on my blog or on our official website, logicgreen.com. All the links will be added in the description. But the idea here, is for you to test, so to know what kind of products that you can develop for your company using the approach that we are sharing here. So for this video, we are talking about the ABC analysis, so we should go on supply chain optimization. Here in the first page, what you will have is a presentation of the different modules that are included here. So here so far we have 3 modules. Probably we are going to add more, even if now we are more switching to developing AI agents and automation. So you select ABC analysis. Then you will arrive at a brief presentation of this module, what we call the product segmentation module. You can see visuals that are used in the presentation. And then if you move to the analysis tab, you arrive where you can select the different parameters. When you click on launch analysis, as I'm doing now, the visuals appear. You have 3 visuals so far. So the first visual is basically the APC charts that I showed you, that are showing on the y-axis, the coefficient of variability. So if it's higher than 1, we assume that the demand is not stable. If it's below, it's pretty stable. And then on the x-axis is the contribution to the turnover. But you can also say, or contribution of the quantity. And here, this is where you select that. But I will go to the parameters later. Then you have the Pareto chart. So the Pareto chart is showing the cumulative percentage of SKUs, of quantity or turnover on the x-axis. And on the y-axis, on the x-axis is the cumulative percentage of SKUs. So, for instance, here we have 20% of SKUs on the red vertical line, and on the y-axis is the percentage of sales. So it can be in quantity, or if I select here in turnover, it will be in turnover. And the idea is to compare your product portfolio with the 2080 rule. So the 2080 rule is saying that, okay, normally 20% of your SKUs are making 80% of the turnover or the quantity. And for instance, here, what happened is that if you look at the 20%, the top 20% of the SKUs, they represent less than 60% of the total turnover. What does that mean? That means you have a high number of slow movers and your fast movers are not that fast, basically. And here you have, so we generate a kind of automated insights using plain English. And the last one is a visual showing you basically the percentage of quantity with the percentage of turnover. And the idea is to show you, okay, what kind of items do I have? Do I have items with limited quantity but very high turnover? So that probably are very important. So for instance, if you go here on the quantity, this one could be quite important because what is good is that it has a stable demand, which is a good news, but it represents only 0.5% of the units, but more than 1.4% of the turnover. And here you can point, you can have visibility. So these are dummy data, of course, and we don't use customer data for the demo, but what you can see, you have information about the family, about the class, so it's pretty easy. So how to set up the parameters? So here you have a section that could explain you how to set up the parameters and what kind of parameters do you want to set. So let's say that the inventory management team is asking you for a kind of ABC analysis. Maybe the first question to ask you, say, do you want to have an analysis on the whole product portfolio or do you want to remove outliers? And to remove outliers is basically this parameter of the maximum coefficient of variability. You know, if you remember well, the coefficient of variability is the standard deviation divided by the average. So here I put at 4, but let's say, I don't know, that 8. Yeah, here, for instance, this SKU has been removed because it has a demand coefficient of variation that is 5. So that's a way for you basically to clean the analysis and remove the outliers that's probably not interested. Then the other parameters is, so the first one is the limit A, what we call the limit A, is basically what percentage do you think are the class A? So if you assume that the class A are the top 20% of the SKUs, you put 20%. And then the limit B is basically, the same, we define the limit A as the top X%. The limit B would be the following Y%. And for instance, here, the limit A is 20% and the limit B is 50%. So let's say that we move that to 5, right? Like in the presentation, and here we move that to 15. You see, the visual are automatically updated. And yeah, here you have a kind of ABC chart that looks like more what we had in the presentation. And then you have the different color mapping. So here, the color mapping is basically based on on the class. So the blue one are the class A, and here we say like the top SKUs. On the B, you have the class. Oh no, in red you have the class B, and the rest, the C, you have in green. But what you can do is, for instance, ask for the focus. And here, what is the focus? It's basically to say you have 3 types of SKUs. You have SKUs with stable demand, right? And these are the ones basically that are in class A and class B with a coefficient of variability that is below 1. And these are this one. So for this one, you can implement inventory rules that are basically fixed but optimized. You don't have to take much care. It can be automated. Then you have the very high importance. So these are the SKUs in class A and class B. Sometimes people only use class A. That requires careful attention. So you can use a rule, but also you have to check if the rule is efficient frequently because their contribution to the turnover is pretty high and their demand variability is also high. So it can be unstable and maybe you have to sometimes, I don't know, for instance, add safety stock to ensure that you don't have stockouts, for instance. And the rest, these are the low importance. So these are the green. Basically, they are the small movers. Here you can put a fixed inventory rule. You can use the one of your ERP. So these are the items that have very low importance. So even if you have stockouts, that will not impact your turnover. Okay, and then, so the third color mapping is based on the normality test. So here we use the Shapiro test to know if the distribution is normal. Why do we do that? It's because many inventory management rules are assuming that your demand is normal, but for most of the time, new demand is not normal. So here, if the demand is normal, it will be in blue. If not, it will be in red. And then we added another field is the family. So you can know, okay, what kind of family? Do you have like a specific family that only has, I don't know, unstable demand? But here what we can see is very sparse. So that would be, and then as I told you, you can move from quantity to turnover pretty easily. So I guess that's all for the demo. I hope this gave you enough insights on how easily using Python you can help support your inventory management team, but also the business team to bring a understanding of the product portfolio. If you need more examples or case studies on how to use analytics to optimize your supply chain and deep with the applications that you can deploy, don't hesitate to go to our website, logicgreen.com. I will add the link in the description. And I would advise you to go to the case studies. And in the case studies, you have multiple case studies. And for each of them, you have a statement of the problem, sometimes based on an actual problem, and then a solution using analytics. In the end, you have the presentation of, you have a link to the right module in the demo version. So for instance, you have this one for the product segmentation and ABC analysis, where here you can have more detailed explanation of the theory behind and the formulas used. And then in the end, we present the demo and explain you how to use it. So for instance, you have some for supply chain optimization, but as you saw probably before, we have some modules that are focused on sustainability. And for instance, you have the sustainable supply chain optimization tool, where basically we are using linear programming to set up the optimal network to minimize cost or minimize the environmental footprint of your company. And here you have a detailed explanation of the case study. That's basically how I advise people to go to the case study. And then in the end, you have the link to the Logic Green app and it explains you how to use it. So don't hesitate to use the comment section if you have any question. If you want me to introduce another kind of case study using analytics to solve a supply chain problem, don't hesitate to share it in the comment section. Thank you.